It's called looping. Of course, in this case, you're doing 1 to I period. Technically, you can write step 1, but if you don't write it, it is assumed that you're going to increase it by step 31. All right. The for loops have to be closed with next, a statement that says next the counter name. So anything I write in that block is going to be repeated that many times. So let's do this. First and foremost, let's get iMoney started. First time we use it, it's going to be iCash, which is the first period's payment. So I'm going to say, take this, and I like indenting stuff. Again, internally, it makes no difference whatsoever, but visually, you know that it belongs to that block. PV for growing annuity plus, what's my simple present value future? I don't know if I wrote that's correct. If I haven't, it wouldn't have given me those suggestions for the arguments. The amount is going to be iMoney, whatever that period's money is. I already calculated I rate, so I'm going to make this equal to P rate. In this case, freak is 1, and I time is I row. This calculates present value of amount iMoney at the interest rate of P rate. Annual compounding is only 1, and for I row periods. I could have converted into months and stuff, but I didn't need it. And you may have thought he wrote an equation where the solution is 0. If you think of that equal sign as an equality operator, you would have been correct. Because x equals x plus something is solved for only x equals 0, right? Most of the time. But that's an assignment operator. Here's what that means. Go to that function, ask for that calculation. It's going to give you a value. That's basically the present value of money you're going to get on that period. Take that amount, go to the current value of that counter we have. It's in the memory. Go to that spot in the memory, grab the value, add them up, put the sum back to that location. That's what that line means. In fact, we're done. Oh, we're not done yet. I'm sorry. I need to calculate what iMoney is going to be the next period. That was the whole reason why we needed this function. Well, whatever iMoney was, it's going to be 1 plus P grow. That's it. So if that P grows 1%, I'm going to grow the current amount of money I'm getting by 1%, knowing that I'm going to get that the following year. But when I go back to the beginning of that loop, now iMoney is what I need. Okay. So think of it this way. Let's say iCash is 100, and for the sake of argument, let's assume growth rate is 12%. Monthly growth rate is 1%, whatever the annual growth is. First time I go into the loop, I row is 1. So here I already know that iMoney is 100. P rate is whatever it is. Let's call it 0.5% if APR is 6%. And calculate the present value of $100 1 month from now, where the period rate is 0.5%. and report that to me. I'm going to add that to 0 because that's where I started. And now in memory, I have the value of the first payment. Then next, calculate the next payment, $100 times 1 plus 1%, because I assume monthly growth rate is going to be 1%. That's $101. We're done. It goes to the next IRO. Next IRO is 2. Okay. And here, the only thing that depends on IRO is that number of periods. Now it's going to take IRO as 2. But I already was prepared and calculated the amount of money that I was going to get in period 2. That's stored in iMoney. And there, calculate the present value of that, added to the previous one. At that point, PV for growing annuities stores the present value of the first 2 payments, the sum of them. Be careful, calculate the present value, money you're going to get for the 3rd period. Go back to the beginning. It's just rinse and repeat. That's it. That's the beautiful part of being able to loop like that. I didn't have to write 35 different codes for 35 different months. Okay, by being careful about using that counter. In fact, we're done. There isn't anything else I need to do. So let's make a calculation. First, I'm going to do it annual so that we don't have to worry about the other stuff yet. So let's see. Uh, First dollar, let's do 100, APR 6% times 10, and growth is going to be 2%. Okay. If I actually did those, 1, 2, it's always a good idea before the test. This is the first cash flow. 1 plus that cash flow raised to the power of the growth rate. Make sure you fix it. Not raised to the power. I'm sorry. That times 1 plus the growth rate. Make sure to fix it. These are the payments. And I have my trusted MPV function. Since I'm doing this annual, that's the answer I'm supposed to get. Okay. Let's see if our function is going to give us that answer. If not, that means either I made a mistake in calculating this or my function is crap. One of those. We call this growing PV for growing annuity. Okay, my iCash is $100. I rate is 6%. I freak, I just assumed 1 here. I time is 10, and I grow is 2. Okay. Oh, okay. This one's I time is a double precision, but I didn't make that double precision. Well, let's do this. Then I will. Again, this is because I require the explicit stuff. I basically killed myself. Was that one? And already calculated. In fact, let me shift that to here. And let's calculate the difference between the two. And I'm going to give that scientific notation. Well, it is precisely zero. Sometimes the way Excel calculates things internally and the way you calculate may not go through exactly the same set of sequence of arithmetic operations. Since computer numbers cannot be represented with infinite precision, there will be slight differentials, but that should be less than typically 10 to the power negative 14 or so, the so-called machine epsilon. Machine epsilon is such a number that on any computing machine, if you add the machine epsilon to 1, it gives you the answer as 1. If any number that is smaller than machine epsilon. I mean, if you want to know, 1 plus 10 to the, or e negative 17 minus 1. That should give you e negative 17, right? Plus, come on, e. Oh, let's do 10 to the negative 17. So it says 0, even in scientific notation. But if I did that for 10 to the 13, it does not say 0. Okay? Why? Because machine epsilon is something 10 to the 15.